Part B now asks how much heat is required to convert 5 liters of ethanol at minus 140. Where would that be on this graph? Somewhere down here, right? To the vapor phase at 78. So they want to figure out how much energy it takes to get through this part of the graph, that part of the graph, and that part of the graph. Okay? So what we're going to have to do is figure out what Q is here, because Q is the energy that is involved. What Q is there, and then add the values together. But it's not as easy as saying that we're just going to calculate Q and add them together. It's a little bit more involved than that. Let's do it, because I want you to see how this is physically done. So let me erase this business over here. Come on, silly thing. Should be able to just circle it and tap it and erase, right?
I'd be able to use that triangle shape tool to elect the eraser.
Can you use the shape tool to erase within the shape?
Maybe.
I've got to try that. All right, anyways. Okay, so what do we say? How do we calculate Q in these sloping portions? Well, if this is C, what formula do you know that has Q and C in it?
MCAT.
Q equals MCAT. So we're going to use Q equals MCAT here and there to figure out how much energy is needed to get through those parts of the graph. All right, so we change color. So I'm going to need Q equals MCAT. Here, and Q equals MCAT there. Okay, well, what's the mass of ethanol that they use here? No. Look at part B. 5 liters. They didn't give me a mass. How can I get a mass out of 5 liters? You use the density. All right, so I'm going to go over here in the margin. The density is the mass over the volume. The density of this stuff is 0.789. I don't know the mass. The problem is that the density was, and this is where you have to be really careful about writing down units. It was given to you in a gram per milliliter unit, right? How do they give you the volume? Liters, so you have inconsistent units. So what would you want to do here? Change it to milliliters. All right, what's up, Patrick?
So in MCAT, this basically you're looking at, but the delta is,
Change in.
so is that enthalpy?
Nope.
What is so
We're getting there. Just give me a second. We're getting there. Okay, so you've got 3,945 grams of ethanol in 5 liters. That's the number that you put in for M, 3945. And it's driving me insane. What's it doing? Okay, what's C? For this part, it would be 2.3. For this part, it's 0.97. And then delta T is your change in temperature going through this part of the curve and going through that part of the curve. All right, so for this top part, it would be 78 minus negative 114. And then, let's see, for this part of the curve, it'd be negative 114 minus negative 140. Okay, so let's just calculate these real quick. I get a ridiculously large number. 78 minus negative 114. No, that's just a dot. I get a huge number. And one of the things you have to watch for here is, what are the units of this? Yeah, this is in joules, okay? So it might be worthwhile to go ahead and divide by 1,000 to change it to kilojoules. I get 1,742 kilojoules. All right? How are you going to figure out what unit? look at your constant that you put in for C. And what you're basically calculating is an energy unit, all right? Look at the constant. It was in joules. I just had to divide by 1,000 to change it to kilojoules because it was such a large number to deal with. Okay. All right, let's do the same thing down here.
Or are you
So-
allowed to give your answer in different units? than
You
the
can, but you'll see what the logic is behind going to kilojoules now. In a second. There's a second reason why I'm doing it. It's not just because it's so big that I want to write fewer digits. Okay, this ends up also being a very large number, the second one. And so I'm just going to go ahead and change it. This was in joules. So I'm going to go ahead and divide by 1,000 to change it to kilojoules. This is 99.5 kilojoules. All right, any questions so far? So I know how much energy it takes to go here and there. Now I got to figure out how much energy it takes to get through the plateau. And so now we're going to come back to your question. This here, this plateau, represents the enthalpy of fusion. And if you watched the first video this week, where I talked about enthalpy, I showed a graph, an energy diagram of an exothermic reaction, and then an energy diagram for an endothermic reaction. And I talked about how the enthalpy of a reaction is basically the difference between the bottom line, where the reactants start, and where the products end up, right? That difference right there. And then over here, it's the difference between this line and that line. Okay, it's that difference between where you start and where you end, all right? And I also told you that delta H was really nothing more than Q in a per mole unit. So this Q here is like the total energy based on whatever number of particles you put in the beaker. But when you do it, you take that number that you measure out of the calorimeter and you do it in a per mole unit. Now you no longer call it Q, you call it delta H. All right? So we have this equation, delta H equals Q over mole. How do you isolate Q out of that equation? So Q is going to be delta H times mole. Right?
Your pen is Jake.
I know, both of my pens are messed up right now. It could be that I just have too many things open on my computer and my computer can't process. But anyways, do you guys see that? Algebraically speaking, if you're sitting in your algebra class, if I want to get Q by itself, it's delta H times mole. Did we not just calculate Q here? Did we calculate Q here? What's Q there? What's your delta H? 5.02. And what's the unit for that? Kilojoules. How many moles did I get? Did they tell me how many moles of ethanol I got for part B? No, what did they give me? They gave me liters. But I'm halfway through, right? Because I was able to convert it to grams. And now I can change that to mole. It's involved, but I can do it, right? How do I change that to mole?
The period.
You divide by the molar mass off the periodic table. It happens to be, I think, 46 grams in 1 mole. All right? So 39.45 divided by 46. I get 83.6 moles. Yeah, my pen really is messed up now. Okay? That's what you do. You multiply this by 83.6. I get 419.6. What's the unit? Why do you think I converted these to kilojoules? Because now I have to add them. And you can't add joules to kilojoules because those are not consistent units. You either add kilojoules to kilojoules or you add joules to joules. But you can't add joules to kilojoules, right? So I went ahead and converted those to kilojoules, so now when I do the addition, I don't have to do any extra manipulation. All right, so what's the total energy? It's 1742 plus 99.5 plus 419.6. So I get 2,261.1 kilojoules. That's how much energy it takes to basically get 5 liters of water to go from -40 in the solid form to 78 degrees where it's boiling. That's not a ridiculously large amount of energy. It really isn't. And it shouldn't be. Ethanol, for the most part, is nonpolar. It shouldn't take a whole lot of energy to get it to boil. All right? Or most of it's nonpolar. It is capable of forming some hydrogen bonds through its hydroxyl group, but all right?
That's the
And these
conclusion
numbers
of
are
it.
not out of line.
Bye.
Because if you